Hello there, CP Algebra 1B, and welcome to some concepts that are a little bit newer, okay? So I know we're learning these online, but it really builds off of your knowledge of square roots, factors, and everything. So again, just do your best throughout these. If you do not have these printed out, simply write down the examples and let's go through. So our essential question today is, how do you simplify square roots, okay? Now, if you don't also have a graphing calculator or the app, it's a great idea to have those. In general, though, if you type in the square root of 448 and you hit enter, and you get 21.1660149, all that jazz, okay, you might be like, well, that's simplified. But in the mathematics world, it is very improper. Notice how it does not repeat. There are no fancy patterns. This is what we refer to, if you remember, as an irrational number. It's irrational, okay? So the idea of simplifying square roots is we can still do something else with this. It's kind of trimming it up so it looks nicer, and we can then do different operations with it, okay? So we're not just typing these into the calculator. That is a nice way to check your answer when you're done. The way we're going to go about these is, so with 448, one of the first things you want to recognize is that we want the perfect square, okay, factors that go into that. So let's just think, and here is a little chart that if you want to have with you, you can always do that. You can always write this down. So what I'm most concerned about are the perfect square factors that go into 448. If you don't know your perfect squares, that's fine. Just know 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 is 16, 5 is 25, 6 is 36, 7 is 49, 8 is 64, 9 is 81, 10 is 100, 11, 121, and 12, 144. Yes, there's more. You can always just type those in your calculator. 13 squared, 169, so forth. So get used to recognizing these different numbers. Now, the idea with 448 is we want to look at these big perfect square numbers. I'm going to highlight them in blue. These numbers, and you ask yourself, what one of these is a factor of 448. So factor or divides into 448. And the key thing is you want to start from the bottom and work your way up. You want to start from the biggest one and go up. So let's try 448, and let's actually divide it by that 144. Okay, does it work? No, okay, so since we have a decimal there, that is not a factor. Let's try 448 divided by, working our way up, 121 perhaps. Still nothing. 448 divided by 81. Still nothing. 448 divided by 64. And boom, there it is. So 64 is the perfect square we want to consider. So we'll rewrite this, imagining it as the square root of 64 times the square root of 7. 64 times 7 gets you 448. Key thing, please write the perfect square number first, okay? Now the magic, there's always magic in mathematics. The magic that occurs is the square root of 64, hey, we know that that's just equal to 8. So that's just going to break down. Now the square root of 7 does not break down, okay? It stays the same. Here's my little skull because I see students want to get rid of the square root. We just leave it as square root of 7, and there's your answer, okay? It'll get quicker, I promise, but first time going through it, taking our time. So first step, find the biggest perfect square and what it multiplies to. Reduce the perfect square. Okay, so reduce it and leave the other part the same. 8 square roots of 7. Notice if you want to check and you type in 8 square roots of 7, you get that same funky decimal that we started with. This one just looks cleaner. It's ready to go. All right. So first example in the books. Let's write down another one and try it out. So square root of 100. This is an easy one. Okay. First off, it's already on our list. Okay. So again, it's asking what times what, or what times itself is 100. If it's already on the list and you already know, okay, you can just write it as 10. Another idea to check, square root of 100 is just 10. Boom, boom, boom. So nice and easy, 10. Now, no square root sign over it. It's just a happy little 10 all by itself. Other things I see students do is think of it as 10 and 10. Well, that's not exactly the right idea because neither of those are perfect squares. So just calculator first. So calculator first. Or if you just already know, you can just use your brain. That's a brain. Okay. And just square root of 100 is 10. Okay. Let's go more traditional example here. 75. Okay. So you try square root of 75. Whoops. Okay. It is not a perfect square. You get a funky decimal. You can write that down just to reference in the end. But here is now where we want to break it down now. Okay, first number is going to be that perfect square. So even write a square there if you'd like. The second number is just going to be some other factor. The biggest one that goes into 75. So if you kind of work your way down, 75 is below 81. 64 is not going to go into it. You can try, but you'll kind of notice little patterns here. 49, 36, 25, and 3. Okay, it's like quarters. 3 quarters, 75. So square root of 25, square root of 3. Notice again, square root of 25 is in that box. That means this one can break down just to a regular old 5. Square root of 3 is just itself. Does not break down because square root of 3 is an irrational number. So we just leave it like that. You don't even need the multiplication sign in between there. You just write it out. Okay. Number 4, 392. So pause, give it a shot. First idea, remember, break it down into a perfect square radical and a regular radical. Reference either your note card, if you have a note card of all the perfect squares, or just try and divide it by things. So 392. Not 64. Not 81. Not 36. This is a tricky one. Okay, so here is one particular case, and I'll explain it to you a little more here. 4 and 98. So there is a bigger perfect square that goes into it, but let's just check out this one. So 4 and 98. Okay, so we find that one. Now the idea is, so 4 can become 2 and square root of 98. Now, if you don't get the biggest square root first, which in this case we did not because we didn't have it in our list, it's okay, but it can still be broken down more. So now you're going to want to repeat that process with 98. And don't forget the 2 out front. So now let's consider 98, and let's divide it by a few of our perfect squares. Okay, 36. Let's try 4 again. Nope. Okay, and 49 and 2, I notice, are the next pair. So square root of 49 and square root of 2. Okay, now what happens is, so let me rewrite this. This is square root of 49. I wrote it in a box just so you know it's a perfect square. Square root of 49 is 7, and 7 times 2, and then you have the square root of 2. Okay, lastly, 7 times 2, they're non-radical. They would multiply together, and 14 roots of 2. So if you don't get the biggest square root, it's always a good idea to check, does another square root go into it? So check that it's most reduced. Okay, if right off the bat, say you knew 14 squared, okay, is 196. If you already had 196 and 2, you'll also happen to get right to the 14 roots of 2. So that's why I emphasize you want to get the biggest square first. So it might be helpful to write down some bigger perfect squares if you don't already have them. Okay, so like 13, 169, 14, 196, and so forth. Okay, simplifying square roots with variables. It's really not too bad. Okay, that will be our next lesson. I would like you guys to stop there for today and try out some of the practice problems with those particular examples. Okay, and then we will catch up with variables in the near future. Great job, guys.